All right, so there was one thing I wanted to get to in class today that we didn't quite make it to. So I wanted to give you guys the ability to get that, and it was the rules for finding limits of as x approaches infinity, or negative infinity. They both kind of work pretty much the same way. So our limit as x approaches infinity of some polynomial, um, of a polynomial. So we have p of x and we have like a q of x, so another polynomial on the bottom. So we have some fraction happening here. Um, we have three cases, all right? So the degree of p of x is larger than, let's start with smaller than, is smaller than the degree of q of x. Okay, so in this case, the largest exponent on a variable in our denominator, which is q of x, the largest variable on an exponent in our denominator is larger than the largest variable on an exponent in our numerator, which is p of x. In this case, the denominator, q, the denominator is going to grow so much faster than the numerator that it's just going to get pretty much out of control. It's going to get out of control, and so when we start dividing smaller numbers by increasingly larger numbers, our limit as x approaches 0 is going to be 0. Whenever we divide a small number by an increasingly larger number, we're going to get that 0. We're going to get closer and closer to 0. Okay, so there's option A. If the numerator's degree is smaller than the denominator's degree. Second option is when we have the degree of our numerator is equal to the degree of our denominator. Again, we're looking for that largest exponent on a variable. Let's change your color. Where are you? Let's see, properties. There we go. There we go. Let's make you blue. All right, then we go back here. Okay, cool. So degree of our denominator is equal to the degree of our numerator. When that happens, then we have a situation where we end up with where the limit, what? Stop black. Silly black marker. I wanted to use blue. When that happens, we have a situation where the top and bottom, once we start getting really, really big, are both increasing about the same amount. And the thing that it's determining what our numbers are going to end up being, once we sort of get rid of all the stupidly big numbers, is going to be those coefficients. So remember, we always have a polynomial that's always ax to the n plus bx to the n minus 1 dot 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 dot. This x to the n is going to be our dominating force of our polynomial. It's going to grow so much faster or so smaller than our other stuff that it's almost like the other stuff pretty much doesn't exist. So we can get rid of it, and we end up with all right, sorry about that. I had to pause for a second. So we have some polynomial where we have this as our largest portion, divided by some polynomial where we have, instead of using a, let's use alpha x to the same exponent, that same n, and then again, whatever else is happening, we don't care because this is the biggest part. This is the thing that determines our degree. So in this case, we can essentially reduce out our x to the n's, and our fraction is going to be the leading coefficient of the top divided by the leading coefficient of the bottom. So I'll write that as this. So our leading coefficient, so the number attached to the variable with the largest exponent. So leading coefficient of the numerator, leading coefficient of p of x divided by our leading coefficient of q of x. Okay. So from here, we have one last condition that we have to worry about, and that is where the degree of the numerator is equal to, or is greater than the degree of the denominator. So I'll do that one in green. So the degree of our numerator is greater than the degree of our denominator. In that case, we have to be really careful. It's either going to be positive infinity or negative infinity. And so if that's the case, um, sorry, x approaches infinity. It's either going to be positive or negative infinity. You have to just kind of plug some numbers in and see what it's getting close to. Is it getting more and more positive or more and more negative? All right. So, and again, all these things are true when you're either approaching positive infinity or negative infinity. Um, so again, to recap, um, up top in the red right here, if the degree of our numerator is smaller than the degree of our denominator, our limit is always going to be 0. Always going to be 0. And then if we have the degree of our numerator, if that equals the degree of our denominator, then we take the leading coefficient, or the number that's attached to the number that's attached to the largest exponent. We take that, and that divided by the number that's attached to the largest exponent of the denominator, make those two things into a fraction, and that is our limit. Our limit as x approaches infinity. Again, or negative infinity. And on the bottom, essentially we just have to take and plug in large numbers and say, is this going to be positive or is this going to be negative? I'll do an example of that here in a second. But if the degree of the numerator is larger than the degree of the denominator, our limit as x approaches infinity, or as x approaches negative infinity, limit as x approaches infinity, is going to be either positive infinity or negative infinity. One of those two, what will be the case. So I think these first two are pretty straightforward. So let's take a look at an example of this last one. All right, so our limit as x approaches, let's say, negative infinity, of 4x cubed plus 5, 4x cubed plus 5 over, let's say, negative 6 x squared minus 7x. Negative 6 x squared minus 7x. Okay? So what we can do, again, we're just mainly focused on these first two terms up front. The other stuff is not going to have enough of an impact on our problem to have to worry about it. So if we're plugging a more and more ever increasingly negative number in for all of our x's, well, if I have a negative number, so 4 times some negative number and cube that, well, this number right here, is it going to be positive or negative once we cube it? That number right there, is it going to be positive or negative once we cube it? Well, it's going to be negative. So we're going to get some negative number on top, divided by, we take a look at this 6x squared, so negative 6 times some large negative number, and we cube this thing. So a negative times a negative is what kind of number? Well, that's going to be negative. So we have a negative number right here times another negative number in negative 6. So negative times a negative is always going to be positive. So our limit as we approach negative infinity of some of this thing, of this guy right here, is going to be equal to, well, some really, really large negative number divided by some smaller positive number. So it's going to be the same thing as a negative infinity. Remember, your two options when the numerator and denominator are different sizes is going to be either positive or negative infinity. All right, so let's take a look at the same problem. Let's take a look at this same guy right here. If instead of negative infinity, we were going to positive infinity. All right, so this is true for limit as x approaches negative infinity of our function. Okay, So let's take a look and see if we're approaching positive infinity. Well, again, this thing right here and this thing right here aren't going to be impactful enough. They're not going to change as much as these first two terms. They're not going to change as much as these first two terms. So we don't have to worry about them. They can kind of go off to the side for now. So if I take 4 and I take a positive number, and cube it, so a positive number times itself 3 times, what kind of number is that? Well, this is going to be a positive number times a positive number. Positive number times a positive number is a positive number. On the bottom, since this is going to be since this term right here is going to be changing more than any of the other terms on the bottom, that's the one we're concerned with. So we take -6 times whatever that same positive number was, squared. So a positive number times a positive number, so positive number times positive number, is still going to be positive. So we have a positive number times a negative number. In that case, it's going to be a negative number. So we have a positive divided by a negative, which is going to make us go, so we have a positive divided by a negative, which is going to give us a negative infinity. Okay? So that is how you can work through one of these problems where you have a larger degree on your numerator than in the denominator. Okay? So hope that helped, and I will see you tomorrow. Okay, bye. Okay, I just realized that I'm super dumb. The second half of this was 100% correct. So as we go to positive infinity, you absolutely should get negative infinity, this guy right here. When I was going through this with the negative infinity guy, well, a negative times a negative, when we square it, is going to be a positive. So positive times a negative is a negative. However, up top, so this, I don't know why I wrote a plus sign here. This should be a negative, and then this should be positive infinity. That's 100% my bad. So we have a negative on top because negative times a negative times a negative is negative, times a positive is still a negative. On the bottom, we have a negative times a negative, which is going to be a positive, times another negative, which makes this negative times negative, should be a negative sign. Negative divided by negative is going to be a positive infinity. I apologize for getting that weird. I promise, try a couple of these. You'll be able to figure out your way through it. You'll be able to figure your way through it. Again, look at those biggest terms, plug in a large negative number, whatever. If you want to pick specific numbers, you can. If you want to just say, okay, negative times negative times negative times negative, it's going to be a negative or whatever. Going through it like that is really the easiest way to think through these and figure out what your limit is approaching for these particular types of problems. Okay? Apologies for the confusion, and I apologize for being so wrong, but hopefully I was able to clear it up for you. Okay? We will talk about this tomorrow. Good luck tonight on your homework, and I will see you tomorrow.